In this video, we're going to talk about the law of total probability. It's an intuitive law, and the examples we'll see at this point will look fairly contrived. However, once we've learned about conditional probability, we'll revisit this topic and we'll be able to explore it in greater depth. We begin by defining a partition of a sample space. So a partition is any collection of sets which combines to give the entire space, but without intersecting one another. For example, we might divide the people in a room into three categories: those whose weight is less than 70 kilos, those whose weight is between 70 and 80 kilos, and those whose weight is more than 80 kilos. Every person falls into one, and importantly only one, of these three categories, so it forms a partition of our sample space. We can visualize this using a drawing. Here, our big ol' sample space is S, and now I'm going to cut it into a bunch of little pieces. I'm going to give each piece a name, F1 through F5, and together they will form all of S, but without any overlap. Okay, so now we're going to use partitions to help us compute probabilities using what's called the law of total probability. Let's suppose first that we are given a partition for our sample space, and that E is some event whose probability we are trying to determine. The probability of E is then the sum of the probabilities of E intersected with each of the partition members. That might sound complicated, but it's not. Let's revisit our picture at the top of the screen and draw a typical event E. The area inside of E can be computed by adding together the parts of E which fall into each partition, and that's all that the theorem is saying. So as I mentioned before, our examples at this point are going to look a little contrived, but in that case we might as well think of a ridiculous one. Let's suppose that you surveyed 35 people, and you asked them two questions. You asked them how many cats do you have, and you asked them how much water do you drink every day. You've collected the data into this handy table. The number of cats is on the left column, and the water drank in liters is across the top. So what's the probability that a randomly selected person ends up owning 2 cats? Okay, so you can probably guess how this is done, but let's do it in full detail all the same. Let's form a partition of S by breaking it into the amount of water a person drinks each day. F0 will be 0 to 1 liters, F1 will be 1 to 2 liters, and so on and so forth. So let's take C to be the event wherein a person owns 2 cats, so that the probability of C can be determined by looking at the people who own 2 cats according to how much water they drink. Since 35 people were surveyed, we can just read these probabilities off from the table, like so, which gives us a probability of 8/35. And that's all there is to it.